Hello everyone. Today I will talk about lecture 6. There are some videos recorded related to that, so please watch all the videos that I will share with you on AutoClass. The first topic of this lecture is statistics. So when we talk about statistics as a science, it's not about just a raw number of data anymore. Now we are talking about a science which is dealing with data collection, summarizing data, data analysis, hypothesis testing, and extracting useful information from that data. So one by one, we start from data collection. We should know about sampling methods in order to have the best way for our data collection. And then when you have lots of data, whether you have collected them or you have found them from another database. So you should know how to summarize those data so that you can get idea how to analyze it right after it. So summarizing data is also an important part of statistics. And data analysis and hypothesis testing, which could be also included as a part of analysis, then these two parts is the heart of a statistic itself. Because when someone is a statistician, then in that case, he knows how to extract useful information at the end from those data. So first we have data. Then if you have a knowledge, then based off your knowledge, you can extract useful information from it. If you are a good statistician, then even with not just big number of data, even with small number of data, you can extract useful information about it. But if you don't know about statistics, then it won't happen no matter how many data you have. So we should know about these terms when it comes to statistics: population and sample. So when we talk about population, it means that we are talking about not just number of people. It could be number of items which we are interested in, like height of students in your university, for example. Then the height of students could be the population. What is a parameter? We talked about parameters before when I talked about distributions. You remember, for example, for normal distribution, we talked about mean and variance as parameters of population. So it means that for each population, we can define parameters, like if it is normally distributed, then we say mean and variance of that normal population. But usually we don't have information about the parameters, like height of students. For example, for mean of height of students of METU, then in that case, I need to know about information of height of students for all the university. It could be time consuming if we don't have it in our database. So it also can be costly because sometimes we should give money for people to gather the data for us. So in that case, we may prefer to get a sample from this population. So I can get a sample from this population and find statistics. So these ones are called statistics. X bar and S power 2, which represent mean of the sample and variance of the sample respectively. Okay, so when we talk about statistic, it means that we find them in our sample, and based on them, I predict our parameters. So what I'm doing here, it means that instead of asking about the height of students for all the university, I can get a sample from the university. Like, let's say our statistic class could be a sample. So there are 100 students in this class, so it's much easier to get information about it. then I can ask you about it one by one, and you can tell me about your height, and we calculate it. So by finding mean and variance of the sample as our statistics, I can predict, and we can say also estimate, the parameters. So of course there could be some errors, it is natural, and to minimize the errors, we will talk about it in details, how we can do that. So if you denote population parameter by theta, you can use theta hat for estimator of theta. And when we talk about just a value like this, like x bar, and we predict mu by using information of x bar, which I can calculate easily, then x bar can be the point estimator of mean. And we will talk about it also later. So these are the things I just mentioned. So you can use this slide to read the things that I just mentioned in details. Also the same for this one. And you hear about survey a lot. It means that when you want to calculate mean and variance directly without using samples, then you need to run a survey. It means that to ask everybody about their information, but it is usually costly and is time consuming. So again, to remind ourselves what we are doing in the statistics, we have a population. We usually don't have information about the parameters. So what we are doing is to estimate them using the statistics, okay? And how we do that? By getting sample from our population. So here we showed you the sample. And by running tests, we can say, for example, how much sure we are that the number that we have predicted is close enough to our parameter. So here you can see that we talk about point estimation and confidence interval. So what I have given in the example was the height of students for METU. So let's say I take an average of the students in your class, and it happens to be 165 centimeters. But in reality, for METU, we know that the parameter is 167. So if that's the case, it means that I made an error by 2 units, as you can see here. So my error is 2. So when you want to calculate your error, it's good enough to consider your parameter and find the difference of it by comparing by the statistic. And by using this formula, you can find the error. The thing is that now we use point estimation. It means that just a value, like x bar is just a value, and we wanted to predict mu, which is the parameter of the population, using x bar. So x bar happened to be 165 in this example, and mu is 167. So in that case, you can see I use point estimation. But in order to make it more meaningful, we can even define intervals, like say, for example, 162 and 170. So I predict that the population mean should be inside this interval, and I can say how much I'm sure, like 95%. Then I will check in reality whether this is the case or not. Usually the problem is that I don't have this information to find the error. We just predict and say, based on that confidence level, we are sure that 95% it happens inside this interval. So you see, this constructing such intervals can be more meaningful. Just to say 165 should be most probably the mean of the height of students in the whole METU, not just in our sample, in our class. In our sample, this is the number, and for sure, this is the value, this is true. But for method, that's the reason we are trying to calculate the whole thing, to predict what's going on inside the population parameters. So there are some terms that we should know, especially about when we talk about whether the estimator is biased or not. And dependencies are also very important. I already showed you in previous examples in distributions why dependencies are important, because when you want to calculate a probability, then you know that those events are independent. Then simply for their intersection, you can calculate it. But when they are not independent, that's not the story. So we should know about these things and we should check it. Also for sampling, it makes our calculations much easier when we know that, for example, those samples are independent from one another, and the data also, the nature of the data, and also about the estimators that we are using, whether it could be independent or not, whether they are biased or not. We can check everything. So I will talk about it in details. And there are different types of sampling in general. There are different types of sampling. And for statisticians, we usually use 2 books for 2 different semesters to talk about even just sampling methods. That's how much important it is. But this is out of the scope of our course. So we don't focus on the methods that we can use for our sampling, but just know for data collection, this is very important, that which type of sampling you are using. So there are also some assumptions that we should consider, but for our course, only we use simple random sampling, and you will see that in the examples how we do that. So in the next video, I will talk about descriptive statistics.